What is distance and displacement? To understand the difference between distance and displacement, let us take this example. Suppose we have a person at position A and he wants to travel to position B. So he walks along this path, which is not straight, it's curved, and he comes to position B. In doing so, he covers a distance of 15 kilometers. So distance is the actual path covered by the body. But to find his displacement, we take the shortest part from A to B. This will be his displacement, which could be just not 15. It will definitely be less than 15. Say it will be 10 kilometers. So distance is the actual path covered by the body, while displacement is the shortest path between the initial, this is our initial position, that is A, and the final position, that is B. So if you see here, distance is always greater or equal to displacement. Displacement can never be greater than distance. So here, distance is the actual path covered by the body, while displacement is the shortest distance between initial and final position. So when you look up here, do you think distance can be less than displacement? Can this be true? Can distance be less than displacement? You will definitely agree, no. Distance can never be less than displacement. Distance could be equal to displacement or greater than displacement. When is distance equal to displacement? Here again I have position A and position B. And if the object now is moving in a straight line without changing its direction, in the earlier it kept changing its direction because it moved along a path. Here the object is moving in a straight line without changing its direction. So here you will find that the distance is the actual path covered. Suppose it is 15 kilometers. Your displacement also will be the same because your displacement is going to be between the initial and final position. This is going to be your displacement, which will also be equal to 15 kilometers. So when is distance equal to displacement? When the object moves in a straight line without changing its direction. See, the distance also will be the same. It's moving along this path, and the displacement is also the same. This is distance, and here is displacement. When is displacement 0 for a moving object? For this, let us consider an object at A, and this object is moving along this perimeter of this rectangle. It keeps moving, and then it returns back to its position A. So now this position B, the final position, and the position A coincide. In this case, if I want to calculate the distance, I know distance is the actual path covered by the body. So it is covered here 40 meters, then it goes up another 30 meters, then it will travel 40 meters and down again 30 meters. So the total distance covered by the object is 40 plus 30 plus 40 plus 30, and that is 140 meters. But what will be its displacement? The displacement will be the distance between the initial and the final position. And if you see, the initial and the final position coincide. There is no distance between them. So the displacement will be 0 meter. So when is the displacement 0 meter? When the object returns back to its original position. See, it's coming back here. It has left from here and then it returns back to its original position. This is the initial as well as the final position. So this is initial position and also the final position. So when the initial and final position coincide and the object returns back to its initial position, the displacement is said to be 0. Displacement is 0 when the object returns to its initial position. We could take another example. Say the object starts at this point, it goes up here and then in this direction, and then it returns back to the same position. Here also the displacement in this case will be 0, equal to 0. However, the distance, what would be the distance here? If it is 7 kilometers up and it would be 7 kilometers down, the distance would be 7 plus 7, 14 kilometers. But the displacement will be 0 because the object has come back to its initial position. This is the initial as well as the final position. Give the SI unit of distance and displacement. Now the distance and displacement both have the same SI unit, and that is meter. So we call it M. Both have the same SI unit. Is distance a scalar or vector quantity? And is displacement a scalar or vector quantity? Before that, let us learn what you mean by a scalar and a vector quantity. A scalar quantity is a quantity that has only magnitude, while a vector quantity has both, has magnitude as well as direction. Distance is a scalar quantity because it has only magnitude. Displacement is a vector quantity. It has got magnitude as well as direction. When I say 15 kilometers, I'm talking only about magnitude. It is a scalar, it's distance. But 15 meters east, I'm talking about 15 meters magnitude, east direction. So it is vector. So 15 meters, I repeat again, is distance. It's a scalar quantity. 15 meter east is magnitude as well as direction, and hence it is displacement. 20 kilometers north means it is, I'm referring to displacement. But if I just give 20 kilometers without any direction, this I'm referring to distance. So when I refer to distance, distance is a scalar quantity, while displacement is a vector quantity, because displacement we have both direction as well as magnitude. So we put scalar is distance, while vector is displacement. When we talk about displacement, we need to show its direction, north, south, east, west, or northeast. What is speed? What is velocity? Speed is the rate of change of distance. What do you mean by rate? Rate means divide by time. So speed, we can say, is distance divide by time. That is rate of change of distance. When we come to velocity, we call velocity rate of change of displacement. Rate means divide by time. So velocity will be equal to displacement over time. Now can you tell me which of this is a scalar and which will be a vector quantity? Since we know distance is already a scalar quantity, so speed will also be a scalar quantity. So when we talk about speed, there is no direction, there is only magnitude. So example of speed could be 25 kilometer per hour, or it could be 100 meter per second. This is the example of speed. But since displacement is a vector quantity and it has direction, velocity becomes a vector quantity. So velocity is vector. So when I talk about velocity, I need to indicate its magnitude plus its direction. So if I just say 25 kilometer per hour, it becomes speed. But if I say 25 kilometer per hour northwards or in the north direction, now it becomes velocity. Same thing if I say 100 meter per second, it is speed. But if I say 100 meter per second east, it is now velocity. What is the SI unit of speed and velocity? Although speed and velocity are different quantities, they have the same SI unit, that is meter per second. Velocity also, SI unit is meter per second, because speed is distance over time, and we know distance is measured in meter and time in second, so the unit becomes meter per second. And we know velocity is displacement over time, and the unit of displacement is meter, time is second, so it's meter per second. So both have the same SI unit. When is speed and velocity equal? Let us take example of a body which is at A. So this is its initial position. And now the body moves along a path, goes up here, and then it returns back. So here the object first is moving up, and then it returns back to its initial position. So this also is the final position. So in this case, we already have seen that distance will be the actual path followed. So let us consider the body goes up 10 kilometers and comes back 10 kilometers. So it has covered a distance of 20 kilometers. We'll take the time here as say 5 seconds. So time equal to 5 seconds. If we know distance and time, now we can know what is the speed. So the speed of this object will be distance over time, and that will be 20 over 5. Well, instead of kilometers, we maybe take meters for easier calculation. So I take this as meter, I take this as meter. Here also I'll just change it to meter. So 20 I get here, speed 20 by 5, that is 4 meter per second. So here I had my speed as 4 meter per second. But what will velocity be? For velocity I need displacement. So here we see the displacement is 0. Why is it 0? Because the initial and the final position is the same. See, this is the initial position and this is also the final position. So the displacement is 0 meters. The time is the same. So the time taken for the body to go and come back is 5 seconds. So if we know distance, displacement and time, we know velocity. So velocity equal to displacement over time, that is 0 over 5 is 0 meter per second. So here we have seen that our speed is 4 meter per second and our velocity is 0 meter per second. Is it equal? No, it's not equal. So speed is not equal to velocity. Here, however, we wanted to know when is speed equal to velocity. If we take the same example, here I have an object, say A, and now this object moves up and does not come back. It's now here at this position B. This is, we have taken as 10 meters. Now, what is distance? Distance equal to 10 meters, and displacement is also the same, also 10 meters. See, it covers this, it goes up, but it does not come back. And the time in both these cases, we'll take the time here as 5 seconds. So time here is 5 seconds, and here also time is 5 seconds. So we know, if we know distance and time, we know speed. So speed will be distance over time, which is 10 by 5, and we see speed is 2 meters per second. Now we know displacement and time, we know velocity. So velocity equal to displacement over time, and velocity equal to 10 over 5, and we see velocity is also 2 meters. So here in this we see speed equals to velocity. When has that happened? When the body has not changed its direction. The body is going just in one direction. It is not coming back. So when an object does not change its direction and it travels in a straight line, the speed and velocity become equal. So when is speed and velocity equal? When object travels in a straight line without changing direction. In this first case, it was not equal. Speed was not equal to velocity because the object changed its direction. In this case, the speed is equal to velocity because distance and displacement became equal. So the speed and velocity was equal. So if speed has to be equal to velocity, the object will travel in a straight line without changing direction.